Okay, so 2.5 is mostly all review. It's the slopes of the line. So this is a kind of a brief stroll through memory lane of Algebra 1. We did on Algebra 1, some pre-algebra, even down to like mid-high math 2 when we talked about the slopes of the lines, okay? So if you remember, slope of the line is calculated as, it is the rise over the run. Rise over the run is the slope, and is normally m, right? M is equal to rise over run. So what is the rise? Rise is if you have 2 points that are x1, y1, and x2, y2, the rise is how much, when you go from this point to this point, how much did it go up in the y direction, right? So basically it is the delta y, whereas the run would be the delta x. Okay, so the rise is the delta y, the run is the delta x. The delta y is calculated as y2 minus y1. Okay, and then the run is x2 minus x1. Okay, so the run is how far it went from here to here, right? So in other words, if I drew a triangle here, this is the delta x. The delta x, x2 minus x1. This is the delta y, which is equal to y2 minus y1. Delta x was x2 minus x1. Okay, so hopefully this kind of makes a little more sense now, right? Now that you've been through this so many years. Okay, all right. Interesting fact for those of you, so when you were learning this, you were always taught to make sure that it was y2 minus y1 over x2 minus x1. So it was always this guy minus this guy and this guy minus this guy, okay? Well, if this holds true, I'm actually able to multiply the top and bottom by -1. So if I do that, what do I get? I get y1 minus y2 over x1 minus x2. Okay, so really, you can swap the points and you would still get the same result. Mathematically, you're still going to get the same result. Conceptually, you still should remember it as y2 minus y1, x2 minus x1, okay? Conceptually, this is the correct term, right? Without the negative, without the minuses here, okay? But mathematically, it's the same thing, okay? All right, so let's go to middle of page 182. There is a slope of the line. The rise is the difference between the y values. The run is the difference between the x values. And the slope is just as we had said, okay? So let's see if we can go ahead and use this and do a couple of examples. So let's do example number 1. Example number 1, we have find the slope of the formula, determine the slope of each line. We have A to B. So A is, so this is the first one, A, I guess, A. So we have A is 2, 3, and B is 7, 5. 7, 5. Okay, so the slope is y2 minus y1 over x2 minus x1, 2 over 5. Okay, so your answer is 2 over 5. B, you have D, C is what? C is 4 and -3. And then you have D, which is 4 and 5. Okay, same thing. The slope is going to be y2 minus y1, 5 minus 3. And you have x2 minus x1. The top, you're going to get 8, right? Minus and minus is plus, so it's 8 over 0. Oops. You are never allowed to divide by 0. So you are not allowed to do this. This is undefined. Undefined. It is a vertical line, okay? In other words, if in a vertical line, what's happening is that your run is 0. So you didn't move anything yet. You went straight up. So you have an infinite, really, amount of slope there. But it's really undefined, so we call it undefined, okay? That's A and B. Then we actually have C and D in this one, I think. C. And see, we have point E and F. E is 3, 4. Where F
Mr.
is...
Hahn, Sarah's in the waiting room.
Okay, thank you. Okay, so F is 6 and 4. All right, 6 and 4. So the slope, y2 minus y1, x2 minus x1, 0 over 3. Now this we're allowed to do. You can divide 0 by whatever you want to, and it's always going to be 0. So you have a 0 slope. This is in a horizontal line. In other words, you went a certain amount of run, but you did not rise or fall or do anything, right? So you have 0 there. Okay, let's get to D. In D you have G and H. G is 6, 2. H is 2, 6. So the slope, y2 minus y1, x2 minus x1. So you get 4 on top, negative 4 on the bottom. Slope is negative 1. Negative 1. Okay. All right. Okay. So that's basically it on that. So mathematically, now we should have all this stuff back. And let's go to example number 2. So we have an example number 2. Example number 2. Tony is driving from Dallas to Atlanta. He is 180 miles from Dallas. He is 330 miles from Dallas. Okay, graph the line that represents Tony's distance from Dallas at a given time. Okay, so what do we have there? What is 180? 180 is the mile, okay, so at 3 p.m., he is 180 miles away. At 5:30, which is 5.5 hours, right? We are 330 miles away. So if you take those 2 points, you're gonna have 3, 180, and then you're gonna have 5.5, 330, right? So you want to calculate the miles per hour, which is the slope, right? So if you do that, we get what? 330 minus 180. And you have 5.5 minus 3. So we have 150 and 2.5. 0.5, so that's going to be 60. And on the top, you had miles, right? Because it's 330 miles away, 180 miles away. And the bottom, you had hours. So this is going to be miles per hour, right? Miles per hour, the speed, right? Okay, so that's that. Flip the page. Let's go on the top of page 184. Top of 184, it shows 3.5-1 and 3.5-2. Parallel lines theorem. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines are parallel, okay? So everyone understand why they said first they said two non-vertical lines, okay? They say two non-vertical lines because the non-vertical lines, if they're vertical, right, you have an undefined slope. You can't say anything about the slope, okay? Right? So they have to be non-vertical. And then they also say any two non-vertical lines are parallel. So they now, when you're talking about vertical lines, now you just say they're not parallel. I mean, you don't say that the slope are the same, you just say that they're parallel, okay? 3.5-2, in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of the slopes is -1. Vertical and horizontal lines are perpendicular. Okay, so in other words, if one of the slopes is 2, the perpendicular line is going to be -1/2. Right? In other words, you take the original slope, if it was 5/3, or 3/5, I'm sorry, then you would go ahead and flip it and add a negative to it, right? So you have -5/3. So these two slopes are now perpendicular. These two slopes are perpendicular. If I had, I don't know, -5/2, then the line perpendicular to this slope would be 2/5. You get the pattern here, right? Okay, and you've done this before. Okay, so let's go to example number 3 and see if we can actually use this in examples. Example number 3, graph each pair of lines. Use the slopes to determine whether the lines are parallel or perpendicular on either. Okay, so AB, where A is 2, 1, B is 1, 5, C is 4, 2, D is 5, -2. Okay, so let's talk about the slope between these 2 points. 5 - 1, 1 - 2, which is going to be 4/-1, which is -4. Over here, you're going to get the slope is -2 - 2, 5 - 4, -4/1, which is equal to -4. So the slopes are the same, which means that these two lines are going to be parallel, right? Okay. That's that. Now let's do one more. I'm not going to do all of these. There are 3 of them. I'll do 2 of them. So let's do the bottom one. We have FGHI. F is 1 and 1. G is 2 and 2. H is 2 and 1. J is 1 and 2. Okay, so let's go ahead and take a look at the slopes here. Slope of these 2 points is going to be 2 - 1/2 - 1, which is 1. Slope of these 2 points is 2 - 1/1 - 2. 1/-1 -1. So now you have 1, and if I flip that and take the negative, it's going to be this guy. So these 2 lines are perpendicular, right? They're 90 degrees. Okay, so let's go ahead and stop there and we'll go ahead and get started on the homework. Does anybody have any questions on anything we talked about so far?